our goal for today is to just learn what a degree looks like. We're going to sketch some common angles that are in degree measure, and we're going to identify and sketch what we call coterminal angles. Everybody see where we're at? All good? Okay. You don't have to have a ruler for this. You can definitely, eyeball a straight line. Like I said, I will be taking a protractor to 0 of the angles you ever draw me in this class. As long as you're kind of close with your measure, we're going to be good. Remember, last night's assignment I had you doing basically 2 things. You were taking an angle that was given to you in radian measure and converting to degree. And then I was giving you something in degree measure and then having you convert it to radians. So what I wanted to go ahead and do, today we are just tackling degree measure. That is what we are doing. And today you're getting famous degree measures. Remember I said on the first or second day of class, really we study 3 shapes in this class. Does anybody remember what they are? Circle?
Triangle.
Do you remember specifically what type of triangles?
Well, yeah, right triangles and 30, 60, 90, and 45, 45, 90.
Yes, perfect. So 3 shapes. A circle, we're going to call it the unit circle here in a little bit. The unit circle consists of a circle with 2 types of right triangles shoved in it. 30, 60, 90, and 45, 45, 90. Okay, when we say the names of those triangles, 30, 60, 90, and 45, 45, 90, there's 4 numbers, 4 unique numbers hidden in that set of triangles. They were, yeah, and if we count by 15s, you've hit them all. Excellent. So what I'm trying to say is, I say memorizing in this class, but if you count by 15, multiples of 15 are going to include 30, 45, 60, and 90. So you would hit all of your special right triangles just by counting by 15. So again, that was 30, 45, 60, and 90, and you got your special right triangles covered. So just to step back for a second, that is how we're going to label that circle. We're going to count by 15s, but secretly we're only hitting 30, 45, 60, and 90 as we go around. Before we get too far into that, I just wanted to define for you the word degree. And degree is just a unit of measure for an angle. 1 degree is 1/360th of a circle. Just a reminder, it's a brand new week. What goes on the smartboard should go in your notes. And if you don't understand what you're writing, you want to stop writing. Put your pencil down. Put your hand in the air or wave me over, and I will come over and look at what you're doing. So yeah, a degree is just a unit of measure for an angle. And now you're like, okay, well, what's the measure of an angle, lady? And what we talked about last week, we spent a lot of time talking about it, is how in this class, an angle isn't 2 rays, it's 1 ray rotating around a common vertex. So our measure of an angle is just determined by the amount of rotation from the blank side to the blank side. Does anybody remember the vocab terms that would go in there? Dylan. Terminal is the last one, the first one's initial. Good. So we have the initial side to the terminal side. And we have 2 units of measure for our angles. We have degrees, which we're taking care of today. And then what's the other one? On your homework last night, you were converting from degrees to radians. Just like we have kilometers and meters and miles and yards. Same idea. All right, let's get to counting, kids. The first ones I start with are, I would, if you how you have colored pencils and colors like that on your desk. The first one I would start with is just your regular pencil, because they're going to be the easy ones. So I'm going to go ahead and switch to black here. This is just like my regular pen, pencil, whatever you normally write with. The first one we're we're going to start with angle measure in standard position. I heard Dylan say that earlier. That was good. All of our angles always start at the origin, and this one's going along the positive x-axis there. If I don't trace it, and I don't rotate that ray at all, I've rotated 0 degrees. So that is 0 degrees right there on the positive x-axis. If I spin that angle the whole way around, what's the measure of that rotation? Do you remember? 360. Nice. Thank you, guys. So, ta-da! Those are our first two numbers that you're memorizing. So, if I don't rotate a ray at all, it's 0 degrees. If I spin it the whole way around, it's 360. What if I only went, like, halfway around? Yeah, 180. That's our straight angle postulate from geometry class. Whoop, that looks like 1180. Gotta fix it. It's not neat. 180 degrees. There we go. What if I just went to up here? What if I just spun it up there? I only went to that positive y-axis. What would that rotation be? 90. Nice, nice. So we have 0, 90, 180. What about the negative y-axis? Negative 90 is coterminal with 270. I'm just doing positive rotations today, but oh my gosh, I do love that you thought that was negative 90. I'll put it in parentheses here. That's not one you have to memorize. 270 you do. Negative 90, helpful to know, but not required. Like, I won't ask for that on your quiz. Okay, those angles in our pencil are like, our regular color there. So 0, 90, 180, 270, 360. They're what we're going to call quadrantal. They don't land in quadrant 1, quadrant 2, quadrant 3, or quadrant 4 because they're on the border. So these are going to be our quadrantal angles. They just kind of are on the axis. All right, now we're going to just dive into quadrant 1 a little bit. I'm going to switch to my red. So you might want to grab a colored pencil at this point. Okay, and if I count by 15 degrees, twice, I would get to my very first special number. That angle right in there is 30 degrees. Halfway through quadrant 1, so half a 90, and 15 more than 30 gets me 45 degrees. It's a little light, but that's the one that's halfway through. And then if I add 15 to that, I get 2/3 of the way through quadrant 1. 15 and 45 gets me to 60. So we got quadrant 1 goes 30, 45, 60, 90. Literally, you could shove all of your special right triangles into quadrant 1. So we go 30, 45, 60, 90. Just to go back to my red one, if I come back 30 degrees from 180, this guy has to be 150. If you go 30 degrees past 90, this blue guy up here has to be 120. Oh, that's not very neat. Let me fix that. This guy here has to be 120. And then if I add 15 to that, I get my 135. So we've now done quadrant 1 and quadrant 2. On to quadrant 3. So we did 180. We can go 30 past that. 30 and 180 gives me 210. We could add 15 onto that. That gets us our 225. we could also come back 30 from 270 and get 240. If I take 270 and I add on 30 more, I'm at 300. Add 15 more on, I'm at 315. Couple ways you could look at this last one. I could add 15 more on and get to 330 degrees, or I could just come back 30 from 360. So what you're going to notice is that these red ones are always 30 degrees from our axis in there. Our green ones are always 45 degrees from our nearest x-axis, and our blue ones are always 60 degrees from the nearest x-axis. We'll define this later. The relationship is that's the reference angle, how far they are away from the x-axis. Good times. That was quadrant 4 down there, by the way, in case you forgot. And this, my friends, is your first little thing that you get to memorize. Woohoo! Questions about that? Alrighty, so what we get to do now is practice. Try it without peeking. Example 1, I just wanted you to be able to tell me what quadrant that angle is in. Tell me what quadrant that angle is in. Part A, 130 degrees. What quadrant is that in? Dose. How about B, 285? Nice job. All right, this one's a tricky one. Negative 260. Wow, you're all gonna fight each other over this one. Okay, fun fact, I'm gonna draw a picture of it. Just a little throwback to negative rotation. Sometimes it helps if you're a visual type of person. Negative 90's down here. I think Zach helped us out with that earlier, right? So negative 90's down here, negative 180's here. So I'm doing these angle measures just in reverse. Negative 270 is up here, which means negative 260 is this like skinny little guy in here. So negative 260 would be from here to here. So that, my friends, is in quadrant dose. I'll show you another way to work around that. If you don't want to count backwards, I'll show you another way to work around that. Any questions on that? Okay, the next goal we have is to be able to identify, so this is your workaround. Like if you hated that part C, let's say you want to identify what we call coterminal angles. Let's say you couldn't figure out, use your spatial reasoning to figure out where that was on the circle. What you could do is identify a coterminal angle that is on the circle, that is between 0 and 360. So again, coterminal angles, that was a vocab word a couple days ago. They just mean angles that have the exact same terminal side. So for instance, if I'm looking for a coterminal angle to 30 degrees, what I'm going to do is I'm going to take my 30-degree angle and I'm going to add on one whole revolution. I'm going to spin that spinner around one more time. So all I have to do is add on 360 degrees. So 30 degrees is actually in the exact same spot as 390 degrees. Negative 390 would be in a different spot. So I'm going to find a negative one now, yes, by subtracting a revolution. So that would be negative 330. So if you're a visual person, I can draw you a picture of this real quick. So here's what I did with some arithmetic. here's me just drawing my XY axis, right? 30 degrees, that was one we did in red. So a few minutes ago, 30 degrees is right there. Again, I won't be measuring it with a protractor or anything, but what we were trying to find here are angles that land on top of that 30-degree angle. So if I take this and I rotate this angle a whole way around 360 degrees more, one whole revolution past 30, I'm at 360 plus 30, that's 390. Conversely, I could spin that spinner in a negative rotation, and in which case that was me going negative 330 degrees instead. So these angles, these two other angles, are in the exact same spot as 30 degrees. They share the exact same terminal side. Let's try it again. So let's say I wanted to find a coterminal angle for 150 degrees. So that's when you just kind of, took a second to draw a few minutes ago. So what I could do is just take 150 degrees and add on 360. I just add on that one revolution, and then adding on that one revolution gets me to that exact same terminal side. So what are we looking at here? 110, so 510. I could also take that 150 degrees and subtract 360. And that'll get you that one positive and one negative. So why don't you try that? Finish up B and C for me. So you guys got, I'm thinking negative 210. Yeah? And then this guy here, you're looking at 90 degrees when you add on your 360. Negative 630 when you subtract your 360. Okay, all right. I'm going to go ahead and talk a little bit about your homework. And the last part just has us identifying a coterminal angle between 0 and 360 in order to be able to sketch that coterminal angle. 30 degrees is one we went over at the beginning of class today. No need to find a coterminal angle there because I already know where that is on our circle. It's just in quadrant 1. That's our very first angle that we memorized. So notice I draw a direction arrow, and then I just label that angle as 30 degrees. However, with part B, that's not one we memorized. So I'm going to do a little bit of scratch work first. All I'm going to do is identify a coterminal angle that is between 0 and 360. So I'm going to take negative 270, add 360 onto it, and what I get there is 90 degrees. So I know that negative 270 and 90 actually land in the exact same place. So I'll go ahead and draw that. First by drawing a 90-degree angle. Now be careful, because the actual angle I wanted to draw has a measure of negative 270. So my direction arrow has to go in the negative or clockwise direction. So now I can call that angle negative 270 degrees. And our last one. And that's how you go ahead and sketch an angle in standard position.